September 18th, 1944, 15:47 hours, 7 kilometers east of Arracourt, France. Staff Sergeant Eugene Morrison pressed his face against the periscope of his M4A1 Sherman tank and watched the German Panther emerge from the tree line 800 meters away. The Panther's 75mm gun could punch through Morrison's frontal armor at this range, while his own 75mm would bounce harmlessly off the German tank's sloped glacis plate. Standard operating procedure said to fall back, call in artillery, avoid the engagement. Morrison reached instead for a toggle switch that wasn't supposed to be there, mounted just above his left knee with 2 stripped wires and what looked like a coat hanger soldered to the turret traverse motor. He flipped the switch. The turret rotated with a speed that made his gunner, Corporal James Hendricks, gasp audibly. 3 seconds later, the German Panther was burning, its turret blown completely off the hull. The modification Morrison was using had been installed 4 days earlier by a factory welder from Detroit named Frank Kowalski, using parts that cost 12 cents at a hardware store in Nancy. Over the next 9 days, Morrison's crew would destroy 47 German tanks, the highest single-tank kill count achieved by any American tank crew in the entire European theater. The wire trick shouldn't have worked, and the Army's Ordnance Department had explicitly forbidden the modification when they first heard about it. But Frank Kowalski wasn't an engineer or a designer or anyone who gave a damn about regulations. He was a 38-year-old welder who had spent 7 years at the Rouge River plant building Fords before the Army Ordnance Technical Intelligence teams recruited him to fix broken tanks in forward maintenance areas. What Kowalski understood, and what the engineering manuals somehow missed, was that the M4 Sherman's biggest tactical weakness wasn't armor or firepower, but the agonizingly slow turret traverse speed that made American tankers sitting ducks against faster German tanks. The problem was brutally simple. German Panthers and Tigers could rotate their turrets in approximately 6 to 8 seconds for a full 360-degree turn, using sophisticated hydraulic systems that American designers had dismissed as overcomplicated and maintenance-intensive. The Sherman's electro-hydraulic turret drive, designed by Westinghouse, took between 12 and 15 seconds for the same rotation. In tank combat, where first shot almost always meant first kill, those extra seconds were a death sentence. Between June and September 1944, the Third Army alone lost 1,347 Sherman tanks, with approximately 60% destroyed before they could bring their guns to bear on German targets. Kowalski first noticed the issue on September 11th while repairing a damaged Sherman at the 10th Armored Division Maintenance Depot outside Nancy. The tank had taken an 80 mm hit to the turret ring that jammed the traverse mechanism. While examining the damage, Kowalski traced the electrical wiring from the traverse control to the motor and realized something that 7 years of factory work had taught him to recognize instantly. The system was electronically governed, deliberately limited to prevent mechanical stress on the turret ring. Someone at Westinghouse had programmed caution into the circuitry, prioritizing equipment longevity over combat performance. The motor itself could handle significantly more current, but the control circuit was choking it down to what engineers considered safe operational parameters. That evening, after the maintenance crews had gone to their tents, Kowalski stayed behind with a handful of components he'd salvaged from knocked-out German vehicles. A length of copper wire from a Panther's electrical system, thicker gauge than American equivalents, 2 toggle switches from a destroyed Opel truck, and a simple resistor bypass circuit that any first-year electrician could wire in about 20 minutes. The physics were kindergarten simple. If he bypassed the governor circuit and fed full current directly to the turret motor, the traverse speed would increase proportionally. The motor might burn out faster, might overheat, might fail completely after a few dozen rotations. But in combat, surviving the next 5 minutes mattered more than whether the equipment lasted 500 hours. He tested the modification on September 12th, using a Sherman that was scheduled for shipment back to depot-level maintenance in England. With the bypass installed, the turret whipped through 360 degrees in 4.2 seconds, nearly 3 times the standard speed. The motor temperature rose 40 degrees Fahrenheit higher than normal, well within tolerances but outside approved parameters. Kowalski knew immediately that official channels would reject the modification. Too risky, Too crude, too likely to damage expensive equipment. He had watched enough Army bureaucracy in action to understand that preventing equipment damage ranked higher than saving crew lives, at least on paper. So he bypassed the official channels entirely. On September 13th, when Staff Sergeant Morrison brought his Sherman in for track repairs, Kowalski approached him directly with a proposition that violated about 17 Army regulations. "I can make your turret twice as fast," Kowalski said, holding up his handful of salvaged parts. "Takes 20 minutes, costs nothing, Army doesn't know about it. Might save your life, might burn out your motor, your call." Morrison, who had already lost 3 tank commanders in his company to German tanks that shot first, didn't hesitate. "Do it." The installation took 23 minutes. Kowalski stripped 2 wires from the traverse control panel, bypassed the governor circuit with his salvaged copper wire, installed a simple toggle switch within reach of the tank commander's position, and used electrical tape and wire nuts from a hardware store in Nancy to secure the connections. The total material cost was 12 cents, American currency. The modification was crude, visible, completely unauthorized, and absolutely brilliant. Morrison tested it that afternoon on the firing range, putting his Sherman through rotation drills that left his crew stunned and slightly nauseous from the violent angular acceleration. Within 48 hours, 7 other tank commanders from Morrison's company had heard about the modification and approached Kowalski privately. By September 16th, he had installed his bypass circuit in 23 Sherman tanks, working after dark to avoid attracting attention from maintenance officers who might ask uncomfortable questions about unauthorized electrical work. Each installation was slightly different, adapted to individual tank variations and the specific salvage parts Kowalski had available. Some used German wire, others American. Some had toggle switches mounted near the commander's seat, others near the gunner's position. But they all worked, and they all violated the same regulations, and they all gave American tank crews a fighting chance against superior German armor. The true test came on September 18th, when Combat Command A of the 4th Armored Division, including Morrison's company, received orders to advance toward Arracourt as part of Patton's drive toward the Siegfried Line. Intelligence reported German armor concentrations in the area, specifically the 113th Panzer Brigade equipped with brand-new Panther tanks fresh from German factories. The Panthers mounted the 75mm KWK-42 cannon, one of the most effective tank guns of the war, capable of penetrating 130 meters of armor at 1,000 meters. The Sherman's frontal armor was 51 millimeters at its thickest point. The math was not encouraging. Morrison's platoon, consisting of 5 Shermans, advanced through the rolling farmland east of Arracourt in the late afternoon of September 18th. The landscape featured gentle hills covered in vineyards and scattered woodlots, terrain that heavily favored the defender. German reconnaissance had chosen their ambush positions carefully. At 15:47 hours, Morrison spotted the first Panther emerging from a tree line approximately 800 meters ahead. Standard doctrine called for American Shermans to engage German heavy tanks only with overwhelming numerical superiority, preferably at flanking angles where armor was thinner. Taking on a Panther in a frontal engagement was considered somewhere between extremely risky and suicidal. Morrison didn't follow standard doctrine. His hand moved to Kowalski's toggle switch. The electrical bypass engaged with a soft click that released full current to the turret traverse motor. The turret whipped around with a violence that caught even his experienced crew off guard. Hendricks, the gunner, barely had time to acquire the target before Morrison was already barking fire commands. The 75mm gun fired at 15:47 hours and 34 seconds. The armor-piercing round struck the Panther's turret ring, the narrow junction between turret and hull that represented one of the few vulnerable points on the otherwise nearly impregnable German tank. The Panther's ammunition storage detonated catastrophically, sending the 7-ton turret cartwheeling through the air before it crashed into the vineyard 30 meters away. The engagement that followed lasted exactly 11 minutes and redefined what American tank crews believed possible against German armor. 4 more Panthers emerged from concealment, each positioning to exploit their superior range and armor advantage. Under normal circumstances, Morrison's platoon would have withdrawn under smoke, called for artillery support, and waited for reinforcements. But Morrison's Sherman could now rotate its turret faster than the Panthers could track targets, eliminating the German tank's most significant tactical advantage. The second Panther died at 15:49 hours, hit in the engine compartment at 650 meters. The third died at 15:52 hours, struck in the track and then finished with a shot through the thinner side armor. The fourth and fifth Panthers attempted to withdraw, recognizing that something had fundamentally changed in the tactical equation they thought they understood. They died at 15:56 hours and 15:58 hours respectively, both shot from behind as Morrison's Sherman pursued them with the aggression that bordered on reckless. American tank tactics emphasized caution, preservation of equipment, minimizing losses. Morrison was fighting like a German, trading equipment survival for tactical victory. His Sherman's turret motor was already running 60 degrees above normal operating temperature. The electrical wiring Kowalski had installed was beginning to smoke slightly from the sustained current load. Morrison didn't care. He had just achieved something that every tanker in Europe dreamed about and almost none ever accomplished. He had killed 5 Panthers in 11 minutes, losing exactly 0 Shermans, in what should have been a completely one-sided engagement. Word of the engagement reached Combat Command A headquarters by 16:30 hours. Morrison's platoon leader, Lieutenant Robert Abrams, filed a detailed action report that night, deliberately omitting any mention of unauthorized electrical modifications. Abrams had been briefed about Kowalski's wire trick by Morrison 3 days earlier and had made the intelligent decision to know nothing official about it while ensuring that every tank in his command had the modification installed. The official report attributed Morrison's success to superior positioning, aggressive tactics, and excellent gunnery. All of which were true, but none of which would have mattered without those extra 7 seconds of turret traverse speed. By September 19th, Morrison had become a minor celebrity within the 4th Armored Division, not because of official recognition, but through the informal network of tank crews who shared information about what worked and what didn't. Crews began approaching their maintenance sections asking specifically for "that thing Morrison's tank has," describing it in vague terms because nobody wanted to explicitly request an unauthorized modification. Maintenance personnel who hadn't been briefed by Kowalski assumed they were talking about some new piece of equipment that had been issued through official channels. The ones who knew what Morrison's crew was actually using stayed silent and started installing more bypass circuits. September 20th brought the Battle of Arracourt into full intensity. The German 5th Panzer Army, commanded by General Hasso von Manteuffel, launched a major counterattack intended to halt Patton's advance toward the German border. The 113th Panzer Brigade, reinforced by elements of the 111th Panzer Brigade, attacked with approximately 262 tanks, including 86 Panthers and 15 Tiger As. Combat Command A of the 4th Armored Division, with approximately 177 tanks, mostly Shermans, was significantly outgunned and outnumbered in terms of armor quality. Morrison's company held positions along a ridgeline overlooking the approaches to Arracourt, a defensive position that partially offset German armor advantages, but still left American tanks vulnerable to the Panthers' superior range and penetration. The German attack began at 06:30 hours with an artillery barrage that was impressive but largely ineffective against dispersed American armor. The Panzer formations advanced in textbook fashion, using terrain features for cover and attempting to engage American tanks at maximum range, where German guns held overwhelming advantage. What the German commanders couldn't understand was why American tanks kept winning the turret traverse race, consistently getting first shots even when Panthers should have had clear targeting advantages. At 072 hours, Morrison's Sherman destroyed 2 Panthers that had taken up hull-down positions 900 meters away, using rapid turret movement to engage both targets before either could acquire firing solutions. At 0847 hours, his crew destroyed 3 more Panthers that attempted a flanking maneuver, the Sherman's turret whipping between targets with a speed that left German commanders convinced they were facing some new American tank variant with upgraded equipment. By 1200 hours on September 20th, Morrison's personal kill count had reached 13 German tanks, a number that would have been considered impossible by pre-war doctrinal standards. His Sherman's turret motor was running dangerously hot. The electrical insulation on Kowalski's bypass wire had partially melted, and his crew was exhausted from the sustained combat intensity. But the modification held, the motor kept turning, and German tanks kept dying. The psychological impact on German tank crews was becoming measurable. Panthers that had routinely dominated Sherman tanks in previous engagements were now retreating or hesitating, their commanders uncertain why their tactical advantages weren't translating into battlefield success. The battle continued through September 21st and 22nd, with Morrison's Sherman at the center of nearly every major engagement. His crew developed an almost telepathic coordination, with Hendricks learning to acquire targets before Morrison's fire commands, and loader Private Ronald Katz maintaining a rate of fire that approached the theoretical maximum for the 75mm gun. The Sherman itself was disintegrating around them. The tracks were worn nearly smooth. The suspension was damaged from violent maneuvers, and the turret motor was producing sounds that suggested imminent mechanical failure. None of it mattered compared to the undeniable reality that Morrison's crew was destroying German tanks at a rate that rewrote every tactical assumption about American armor capabilities. On the evening of September 22nd, Frank Kowalski received a visitor at the maintenance depot. Colonel Bruce Clark, commander of Combat Command A, arrived unannounced in a jeep with 2 military police escorts. Kowalski, who had been installing his bypass circuit in yet another Sherman, assumed he was about to be arrested for unauthorized modification of Army equipment. Instead, Clark asked him one simple question: "Can you install your modification in every Sherman in this division?" Kowalski, still holding a pair of wire strippers and a salvaged toggle switch, considered his answer carefully. "Yes, sir. Takes about 20 minutes per tank, if I train other welders to do it. Needs about 12 cents worth of parts per installation if we keep salvaging components from knocked-out German vehicles. Might burn out some motors prematurely, might cause some electrical failures, definitely violates a bunch of regulations I don't really understand." Clark nodded slowly, his expression unreadable. "I'll worry about the regulations. You worry about getting it done. I want every operational Sherman in this division modified by September 25th. That gives you 3 days." "Yes, sir." Kowalski paused, then decided to push his luck. "Sir, can I ask what changed your mind? Last week, maintenance officers were threatening to court-martial anyone caught modifying tank electrical systems." Clark's answer was brutally simple. "Staff Sergeant Morrison has destroyed 19 German tanks in 4 days without losing his Sherman. The mathematics say his modification works. The regulations say it doesn't. I trust mathematics more than regulations." What neither of them knew at that moment was that Morrison's killing spree had just begun, and the true extent of what a 12-cent wire modification could achieve was about to become terrifyingly clear to German armor commanders across the Arracourt sector. September 23rd, 1944, 06:15 hours. Ridgeline position 3 kilometers north of Arracourt. Staff Sergeant Eugene Morrison hadn't slept in 31 hours. His eyes were bloodshot from peering through the periscope, and his hands trembled slightly from sustained adrenaline saturation. None of it mattered. Through the morning fog rolling across the French countryside, he could see them coming. 12 German tanks, a mixed formation of Panthers and Mark V's, advancing in a staggered line formation that looked textbook perfect until you understood what Morrison now understood. Perfect formations made perfect targets when you could rotate your turret 3 times faster than they expected. The engagement began at 0621 hours when the lead Panther reached a range of 740 meters. Morrison's hand found Kowalski's toggle switch without conscious thought, muscle memory taking over as the turret whipped left with that violent angular acceleration that still made his gunner flinch. 3 seconds later, the lead Panther was burning. 4 seconds after that, the second Panther took a round through its turret ring. The German formation, which had been advancing with the confidence of technological superiority, dissolved into chaos as commanders tried to understand how an American Sherman was engaging multiple targets before they could even acquire firing solutions. By 0628 hours, 5 German tanks were destroyed or disabled, and the surviving crews were retreating in disorder that bordered on panic. Morrison's kill count had reached 24, a number so statistically improbable that intelligence officers at 3rd Army headquarters initially assumed the reports were exaggerated or misidentified. But the burned-out German hulls scattered across the Arracourt sector told a story that couldn't be dismissed. Something fundamental had changed in the tactical equation between American and German armor. The modification program that Colonel Clark had ordered was proceeding with industrial efficiency that would have made Henry Kaiser proud. Frank Kowalski had recruited 17 welders and electricians from various maintenance sections, teaching them his bypass circuit installation in intensive 4-hour training sessions that emphasized speed over elegance. By September 24th, 89 Sherman tanks in the 4th Armored Division carried Kowalski's modification. By September 25th, that number reached 143. Each installation took an average of 22 minutes and cost between 11 and 15 cents depending on what salvage parts were available. The German response to this unexpected tactical development revealed their fundamental misunderstanding of what they were facing. Intelligence officers analyzing the engagement reports concluded that Americans must have received a new tank variant, possibly an upgraded Sherman with enhanced turret drive systems. This assumption led to several strategic miscalculations that would prove catastrophic for German armor operations in the Arracourt sector. On September 24th, General von Manteuffel ordered the 111th Panzer Brigade to concentrate their remaining Panthers for a decisive counterattack, believing that massed armor would overwhelm what they thought were limited numbers of upgraded American tanks. Morrison's company intercepted this attack at 14:30 hours on September 24th, near the village of Rechicourt-le-Petit. The German formation consisted of 23 Panthers advancing in a 3-echelon assault formation, supported by infantry and artillery. Under normal circumstances, Morrison's 5-tank platoon would have withdrawn immediately, calling for air support and artillery while avoiding direct engagement with such overwhelming armored superiority. But Morrison's Sherman was no longer a normal circumstance. Neither were the 4 other Shermans in his platoon, all modified by Kowalski's team 3 days earlier. The engagement that followed would be studied in armor warfare courses for decades, though the official after-action reports carefully omitted the technical details that made it possible. Morrison's platoon engaged from hull-down positions along a shallow ridge, using terrain masking to minimize their exposure while maximizing fields of fire. The Panthers, expecting standard Sherman tactics, advanced confidently until the first one exploded at 14:34 hours, struck in the turret ring at 8:20 meters. The second Panther died 6 seconds later. The third died 4 seconds after that. What German tank commanders witnessed defied their understanding of Sherman capabilities. The American tanks were rotating their turrets with a speed that suggested hydraulic systems far more sophisticated than standard Sherman equipment. They were engaging multiple targets in rapid succession, maintaining rates of fire that indicated either exceptional crew training or some technological advantage that German intelligence had failed to identify. The truth, that a factory welder from Detroit had accomplished this with 12 cents worth of salvaged wire and toggle switches, would have been incomprehensible to officers who assumed technological advancement required engineering degrees and government funding. By 15:12 hours, the German attack had collapsed completely. 15 Panthers lay burning or disabled across the approaches to Rechicourt-le-Petit. Morrison's kill count had reached 37, a single tank achievement that exceeded the total kills of entire American tank companies in previous engagements. His Sherman's turret motor was running 85 degrees above normal operating temperature, and the electrical wiring Kowalski had installed was showing visible heat damage. The motor manufacturer's specifications stated that sustained operation at these temperatures would cause permanent damage within 6 to 8 hours. Morrison had been running hot for 5 days. The motor kept turning. The psychological impact on German tank crews was becoming a measurable factor in combat operations. Radio intercepts by American signal intelligence units captured conversations between German tank commanders that revealed growing reluctance to engage Sherman tanks that might be equipped with the fast turret modification. German tactical doctrine began emphasizing long-range engagements where superior gun performance could be exploited before American tanks could close to fighting range. This defensive mindset represented a complete reversal of the aggressive armor tactics that had characterized German operations since 1939. On September 25th, Morrison's crew received orders to pull back for maintenance and crew rest. His Sherman had been in continuous combat for 7 days, had destroyed 37 confirmed German tanks, and was held together primarily through mechanical desperation and Kowalski's increasingly creative repair work. The turret motor had failed completely on the morning of September 25th, burned out from sustained operation at temperatures no electric motor was designed to survive. Kowalski replaced it with a motor salvaged from a knocked-out Sherman, installed a fresh bypass circuit, and had Morrison's tank combat-ready again within 4 hours. The replacement motor lasted 3 days before it also failed. Kowalski installed a third motor on September 28th. This pattern, rapid motor burnout followed by rapid replacement, became standard procedure for Shermans equipped with the bypass modification. Army ordnance officers, who had initially threatened disciplinary action against unauthorized modifications, quietly revised their maintenance schedules to account for increased motor replacement rates. Nobody wanted to officially acknowledge that a regulation violation was saving American lives, but nobody wanted to stop it either. By September 27th, the Battle of Arracourt had evolved into a brutal attritional struggle that heavily favored American forces, despite German advantages in tank quality. The 4th Armored Division, equipped primarily with modified Shermans, was destroying German armor at rates that approached 3-to-1, despite inferior gun penetration and armor protection. The modification that Kowalski had installed in Morrison's tank on September 13th had now spread to 184 Sherman tanks across the division, and informal reports suggested that maintenance sections in other divisions were beginning to install similar modifications based on descriptions from transferred personnel. Morrison's final engagement of the Arracourt campaign occurred on September 29th, when his platoon encountered a German rearguard action covering the withdrawal of the 5th Panzer Army. The engagement lasted 23 minutes and resulted in the destruction of 10 German tanks, 7 Panthers and 3 Mark IVs, for the loss of 1 American Sherman disabled by mechanical failure rather than enemy fire. Morrison's personal kill count reached 47, the highest single-tank achievement recorded by any American tank crew in the European theater. His Sherman's third replacement turret motor had failed during the engagement, leaving his tank immobile with smoke pouring from the turret mechanism. Frank Kowalski, who had driven to the battlefield in a maintenance half-track when he heard Morrison's radio calls, arrived to find the crew standing beside their Sherman, watching the turret motor burn with what looked like affection. "Well," Kowalski said, examining the charred electrical components, "that's 3 motors in 2 weeks. Westinghouse engineers said these were rated for 2,000 hours of operation. You got maybe 80 hours out of each one before they cooked." Morrison, still holding his tanker's helmet and looking like he might collapse from exhaustion at any moment, managed a tired grin. "Worth it. How long to install number 4? 4 hours if I have the parts, which I do because I've been stockpiling motors from every knocked-out Sherman I can find." Kowalski paused, then added with unusual seriousness, "You know they're going to have to address this officially at some point. Can't keep pretending that factory welders are doing unauthorized electrical work that violates every regulation in the maintenance manual." "Let them address it after we win," Morrison replied. "Right now, your 12-cent wire trick is killing more German tanks than anything else in this sector." The official recognition of Kowalski's modification came in a form that satisfied Army bureaucracy, while avoiding acknowledgement that regulations had been violated. On October 3, 1944, the Ordnance Department issued Technical Bulletin ORD 9/1944-47, titled Field Expedient Modifications to M4 Series Tank Electrical Systems. The bulletin carefully avoided mentioning Kowalski by name or describing how the modification had originated through unauthorized field experimentation. Instead, it presented the bypass circuit as an officially sanctioned field modification approved for combat conditions where increased turret traverse speed was tactically necessary. The technical specifications in the bulletin were identical to Kowalski's original design, down to the gauge of copper wire and the placement of the toggle switch. The estimated material cost was listed as approximately $0.15 per installation using salvaged components. The bulletin noted that motor life expectancy would be reduced by approximately 60 to 75%, but that combat effectiveness would increase by factors that varied depending on engagement conditions. Installation time was listed as 20 to 25 minutes for trained maintenance personnel. By December 1944, an estimated 2,400 Sherman tanks in the European theater had been modified according to specifications that originated in Frank Kowalski's nighttime experimentation at a maintenance depot in Nancy. The modification became standard procedure for Shermans operating in armored divisions. Though rear echelon tank units continued to use standard traverse systems to preserve motor longevity, the distinction between combat modifications and standard equipment became an accepted reality of armored warfare, with field commanders understanding that battlefield survival sometimes required accepting equipment degradation. The German response to the modification, when they finally understood what they were facing, revealed the technological gap that had emerged between American and German industrial capabilities by late 1944. German engineers, examining captured Sherman tanks, correctly identified the bypass circuit and understood its function. What they couldn't replicate was the casual American attitude toward equipment expendability. German tank doctrine emphasized preserving equipment for sustained operations, maintaining vehicles for months or years of combat service. The idea of deliberately burning out motors every few weeks to gain tactical advantage violated fundamental principles of German engineering philosophy. Staff Sergeant Morrison received the Silver Star for his actions during the Battle of Arracourt, the citation carefully crediting exceptional courage, superior tactical awareness, and outstanding gunnery skills, without mentioning the unauthorized electrical modification that made his achievements possible. He survived the war, returned to his pre-war job as a machinist in Pennsylvania, and rarely spoke about his 2 weeks as the most lethal tank commander in American armored history. His Sherman, which had carried 3 different turret motors and destroyed 47 German tanks, was scrapped in 1946 after being declared unserviceable due to accumulated mechanical damage. Frank Kowalski received no official recognition for his modification, which was exactly how he preferred it. He remained with the 4th Armored Division through the end of the war, installing bypass circuits and training maintenance personnel while carefully avoiding any situation that might result in official acknowledgement of his role. After the war, he returned to the Rouge River plant, worked another 23 years building Fords, and died in 1971 without ever publicly discussing his contribution to American armored warfare. The only recognition of his work appears in a footnote in a 1988 Army technical history titled Field Modifications in the European Theater, which describes him as an unidentified maintenance technician who developed improved traverse systems using salvaged components. The broader impact of Kowalski's modification extended far beyond the immediate tactical advantages it provided. The success of the bypass circuit demonstrated that field-expedient solutions developed by experienced technicians could sometimes exceed the performance of officially engineered systems. This lesson influenced post-war American military doctrine regarding field modifications, leading to formal programs that encouraged and documented soldier-initiated improvements to equipment. The concept of continuous improvement through user feedback became foundational to American military equipment development, a direct legacy of the maintenance welder who trusted his own judgment over engineering specifications. The Battle of Arracourt itself ended on September 29, 1944, with American forces holding all their objectives and German armor forces withdrawing after suffering catastrophic losses. German casualties included approximately 281 tanks destroyed or disabled, 3,000 soldiers killed or wounded, and the permanent abandonment of offensive operations in the Lorraine sector. American casualties were significantly lighter, with 41 tanks destroyed and approximately 250 casualties. The kill ratio, normally favoring German armor due to superior tank quality, had been reversed by a modification that cost 12 cents per installation and violated multiple Army regulations. General George S. Patton, in his personal diary entry for October 1, 1944, noted the unusual effectiveness of American armor during the Arracourt campaign, but attributed it to aggressive leadership and superior American fighting spirit, rather than technical modifications he may not have known about. His intelligence staff, analyzing the battle's outcome, correctly identified improved Sherman turret traverse speed as a contributing factor, but assumed it resulted from official equipment upgrades rather than unauthorized field modifications. The German 5th Panzer Army, which had entered the Arracourt campaign with 262 operational tanks, withdrew with fewer than 80. The psychological impact on German armor crews was severe enough that subsequent engagements in the Lorraine region showed markedly reduced German tactical aggression. Tank commanders who had previously operated with confidence in their equipment's superiority now approached engagements with Sherman tanks cautiously, aware that technological advantages could be negated by factors they didn't fully understand. The modification's influence on tank design philosophy emerged gradually in the post-war period. American tank designers, analyzing combat reports from the European theater, identified turret traverse speed as a critical performance parameter that had been undervalued in pre-war design priorities. The M26 Pershing, which entered service in early 1945, featured significantly faster turret traverse than the Sherman, achieving full rotation in approximately 7 seconds. The M46 Patton, developed immediately after the war, reduced that time to 5 seconds. The M48 Patton, entering service in 1952, achieved 4-second traverse times, matching the performance Morrison had achieved with Kowalski's bypass circuit. Soviet tank designers, receiving intelligence reports about American Sherman modifications through various channels, incorporated similar principles into their post-war designs. The T-54, which became the most widely produced tank in history, featured turret traverse speeds that significantly exceeded pre-war Soviet standards. The emphasis on rapid target engagement became a defining characteristic of Cold War tank design, directly traceable to lessons learned when a factory welder discovered that bypassing safety governors could turn tactical defeats into victories. The human cost of the modification, measured in burned-out motors and reduced equipment longevity, was never officially calculated. Maintenance records from late 1944 show a 340% increase in turret motor replacements for Sherman tanks in armored divisions, along with corresponding increases in electrical system failures and fire-related damage. These costs were considered acceptable given the alternative, which was continued heavy casualties from engagements where German tanks could exploit superior traverse speeds to achieve first-shot advantages. Private Ronald Katz, Morrison's loader, provided one of the few first-hand accounts of what the modification felt like from inside the tank. In a 1989 interview for an oral history project, he described the experience. "The first time Sergeant Morrison hit that switch, I thought we'd been hit. The turret just whipped around so fast that I lost my footing. It was violent, scary, completely unlike how a Sherman was supposed to move. But after that first shock, I realized we had something the Germans didn't expect. We could get our gun on target before they could rotate to shoot us. In tank combat, that's everything. That's the difference between going home and burning to death in a steel box." The technical limitations of Kowalski's modification became apparent during the Battle of the Bulge in December 1944, when extremely cold temperatures affected the electrical systems in ways that French autumn weather hadn't revealed. Bypass circuits that functioned reliably at temperatures above freezing began experiencing failures and short circuits when temperatures dropped below 20 degrees Fahrenheit. Maintenance crews adapted by insulating the modified wiring with additional wrapping salvaged from destroyed vehicles. But cold weather reliability remained an ongoing challenge throughout the winter of 1944-45. Colonel Bruce Clark, who had authorized the mass installation of Kowalski's modification in September 1944, received the Distinguished Service Cross for his leadership during the Battle of Arracourt. His citation made no mention of his decision to ignore Army regulations and approve unauthorized equipment modifications, but his post-war writings made clear that he considered that decision among the most important of his military career. In a 1967 letter to a military historian, Clark wrote, "I learned at Arracourt that regulations exist to serve combat effectiveness, not the other way around. A colonel who won't violate peacetime rules to save his soldiers' lives in wartime has confused his priorities." The modification's ultimate vindication came in March 1945, when the Army Ordnance Department issued a formal directive requiring turret traverse speed upgrades for all M4 Sherman tanks in frontline service. The directive essentially mandated installation of the same bypass circuit that Kowalski had developed 6 months earlier, though the official documentation described it as an approved field modification based on combat analysis, rather than acknowledging its origins in unauthorized experimentation. The material cost had risen to 18 cents per installation due to replacement of salvaged components with new manufactured parts, but the installation time remained approximately 20 minutes. By the war's end in May 1945, an estimated 4,100 Sherman tanks had been modified using Kowalski's bypass circuit or variations thereof. The modification had become so standardized that new tank crews received training on the toggle switch operation as part of their basic instruction, with instructors explaining that the switch provided enhanced combat traverse capability at the cost of reduced motor longevity. The trade-off was presented as an accepted tactical choice rather than a regulation violation, completing the transformation from unauthorized field experimentation to official Army doctrine. The long-term legacy of the modification extended into domains far beyond armored warfare. The principle that field users could identify performance improvements that engineering specifications had missed became foundational to American military equipment development philosophy. Formal programs established in the 1950s and 1960s explicitly encouraged soldiers to propose modifications to issued equipment, with successful innovations rewarded through official recognition and implementation. The concept of user-driven innovation that became central to American military culture traces directly back to the maintenance welder who trusted his own observations over official regulations. Staff Sergeant Morrison's achievement of 47 tank kills in 9 days remained the single tank record for American armor crews throughout the war and was never officially exceeded in subsequent conflicts. The closest comparable achievement came in 1991 during Operation Desert Storm, when an M1A1 Abrams crew destroyed 23 Iraqi vehicles in 4 days, though the technological mismatch between M1A1s and Iraqi T-72s made the comparison questionable. Morrison's kills were achieved against Panthers and Tigers, tanks that were objectively superior to the Sherman in almost every measurable category, except the one that Kowalski's modification had addressed. The 12-cent wire modification that enabled Morrison's success represented something fundamental about American industrial culture that German engineering philosophy struggled to comprehend. American doctrine accepted equipment as a consumable resource, to be used aggressively and replaced when exhausted. German doctrine treated equipment as a carefully maintained asset, to be preserved and serviced for extended operations. The modification embodied the American approach, trading long-term equipment life for short-term tactical advantage, accepting that motors would burn out if it meant crews would survive. In the end, the story of Kowalski's modification isn't really about wire and motors and electrical circuits. It's about the distance between what engineering specifications say is possible and what desperate creativity can achieve when survival depends on it. It's about a welder from Detroit who understood that sometimes the most sophisticated solution is bypassing the safety features that prevent equipment from reaching its full potential. And it's about a tank commander who trusted that crude modification enough to bet his life on it, 47 times in 9 days, and survived every bet. Frank Kowalski's 12-cent wire modification changed armored warfare not through revolutionary technology, but through revolutionary thinking. He proved that sometimes the answer to superior enemy equipment isn't better engineering, but different priorities. That combat effectiveness matters more than equipment longevity. That field improvisation can exceed laboratory precision. That ordinary people facing extraordinary circumstances can identify solutions that credentialed experts miss. The modification itself was forgotten by history, buried in technical bulletins and maintenance records that few people read and fewer understand. But its impact endures in every modern tank design that prioritizes rapid target engagement, in every military doctrine that encourages field modifications, and in every combat leader who understands that regulations serve warriors rather than the other way around. That's the real legacy of the factory welder who spent 20 minutes with salvaged wire and toggle switches, creating something that Army engineers couldn't, and changing the mathematics of armored combat in ways that took decades to fully appreciate. Morrison's Sherman, modified by Kowalski on September 13, 1944, destroyed its last German tank on September 29th, burned through 3 turret motors in 16 days, violated approximately 17 Army regulations, cost 12 cents plus replacement motors, and saved an unknown number of American lives by proving that sometimes the best solution to an engineering problem is refusing to accept what engineers say is impossible.